Good morning, dear friends. Here is Earth measured. There is a very good day, a sunny day here in Italy. I hope also in England or in the USA. However, I want to speak with you today about the orbit of the Sun and of the Moon. Why? Because we have already spoken a lot about this, but I want to introduce to you another method of calculation because it will prove to be useful also to make a calculation for the orbits of the planets. So I believe that it is useful to introduce this calculation system. Here we have our flat Earth. It is not a disk, I repeat it, but only to simplify this model, I draw it as a disk, and we have the cone of the Sun that is a conical spiral from the Cancer tropic to the Capricorn tropic. In 6 months the Sun goes down and in 6 months goes up. So it is summer here, winter here for us that live in Europe, okay? We have seen with fractal mathematics and also by making a trigonometrical calculation that the age of the Sun when it is summer in 21st of June is 6,670 kilometers, okay, high. This number can be divided in 3 factors: 6 multiplied by 111 multiplied by 10. 6 is the number of position of the Sun. In fact, in a geocentrical model, if you consider all planets, we have Neptune, Uranus, Jupiter, Mars, the Sun, Neptune, Uranus, Saturn, Jupiter, Mars, the Sun. Okay. It is not easy for me to remember. Okay, the Sun is the sixth one, okay? The 6 is the number of position of the Sun. It is completely identifying the orbit and the position of the Sun. In fact, also the second constant, I call it constant 1, because I call 6 the n, the number that describe the position of the celestial body. Then 111 is our constant 1, and it is given, it has a big relation with the 6. In fact, if you make the square of 6, 36, and then you sum 36 plus 35 plus 33 plus 32 till 1, you obtain 666. And then you have to divide again for 6 and you obtain 111. Only to generalize, I have written this formula. It is the summation, I believe it is called, this is a symbol, the summation in English, for x that goes from n squared n, the position number, to 0 or to 1 of x, divided for n, the position number. This formula can consent to us to find the first constant after the position. Then we have another constant that is more difficult to explain. However, it is linked to the fact that we have to refer all orbits to the orbit of the Sun. The planets, the orbit of the planets are near to the orbit of the Sun. In fact, if we watch to the planets night long, we will see that all planets are always near the ecliptic, that is the trajectory run by the Sun during the day, from east to west. Pluto is the planet, the dwarf planet, that is the farther one from the Sun, and it departs from the Sun only 17.9 degrees up or 17 down. All other planets are nearer to the ecliptic during the night. So we have to refer to the sun by taking this number and by dividing for this. So we have 6660 divided this product that is equivalent to this multiplied for n. So n are simplified, and we obtain divided for summation of x going from squared n to 0. And if we make the calculation, you will find for the sun here 111, here 10. Let's try the calculation also for the moon. The moon is the ninth celestial body, because we have, let's see if I can make the list. We have Uranus, Neptune, Saturn, Jupiter, Mars, Sun, Venus, Mercurius, the Moon, that in the geocentrical cosmology was considered nearer to the Earth. We know that it is not like this, but however, only to begin, we accept this hypothesis. So if we put for the number position 9, let's, if you can, take a calculator and you can try to do this formula with 9, you will obtain 369, and for this formula 6660 divided for this number, you will obtain 2. Not perfect 2, we have to approximate a little, but you will see that this is necessary to obtain a trajectory, an orbit of the moon that is near to the sun. However, you obtain 6,642 kilometers, so a trajectory very near to that of the sun. We will use this method also in the next video to make the calculation for each planet, and this will consent us to understand their trajectory. It is important, I believe, to have an idea of the fact that over the flat Earth, the visual astronomy, the nautical astronomy, what we see night long is perfectly describable with our model. Okay, so the flat Earth is coherent with what we see during the night. Okay, thank you because you have watched this video. If you have not yet subscribed, please do that. Thank you and bye bye. Ciao.